Yo, what's up everybody? It's Andrew from Andrew's PC, and we're back again with another deep dive into the world of AI. These functions are the secret sauce, the magic dust, that actually makes neural networks tick. We're talking about the core components that enable these networks to learn complex patterns, make decisions, and basically do all the cool stuff we keep hearing about. We're breaking down the most popular activation functions out there: Sigmoid, Tanh, ReLU, Leaky ReLU, and Softmax, in a way that's easy to understand even if you're just starting out with AI. So, whether you're building your own neural networks or just curious about how this whole AI thing actually works, this video is your one-stop shop for all things activation functions. Let's get it! Alright, let's kick things off with the OG activation function, the Sigmoid. Think of the Sigmoid function like a smooth operator, gracefully squashing input values into a nice, manageable range between 0 and 1. Why is this range so important? Well, it allows us to interpret the output of our neural network as probabilities. Imagine you're building an image recognition model to identify cats and dogs. You feed in a picture of your furry friend, and the network spits out a value of 0.9. Thanks to the Sigmoid function, you can confidently say that there's a 90% probability that the image contains a cat. Perfect. This makes Sigmoid particularly useful in binary classification tasks. One of its main drawbacks is its susceptibility to the vanishing gradient problem. Vanishing gradients happen when the gradients, or the signals that tell our network how to adjust its weights during training, become super tiny. This can slow down the training process and impact the overall performance of the model. Complex networks. ReLU is computationally efficient, making it a favorite for large-scale deep learning models. Now, even rock stars have their off days, and ReLU is no exception. One of its quirks is something called the dying ReLU problem. Imagine a neuron in our network that for some reason always ends up with a negative input. This poor neuron will always output 0, effectively becoming inactive and no longer contributing to the learning process. That's where Leaky ReLU steps in, like that reliable friend who always has your back. Leaky ReLU is essentially ReLU with a twist. Instead of outputting 0 for negative inputs, it allows for a small, non-zero gradient. This small tweak ensures that even those neurons stuck in negative territory can still learn and contribute to the network's overall performance. Last but not least, let's talk about Softmax, the activation function that's all about making sense of the chaos. You'll typically find Softmax hanging out in the output layer of classification networks, where it plays a crucial role in turning raw scores into probabilities. Imagine you're building a model to classify handwritten digits from 0 to 9. You feed in an image of the number 7, and the network spits out a bunch of scores 1 for each digit. Softmax swoops in and transforms these scores into probabilities, telling you the likelihood of the image representing each of the 10 digits. This makes it incredibly useful for multi-class classification tasks, where you're dealing with more than just two possible outcomes emerge. Who knows what the future holds? Maybe you'll be the one to discover the next big thing in activation functions. Thanks for watching, and I'll catch you in the next one.